So what I'd like to start with today is the frequently made mistakes for assignment 2A. This is the official version of that discussion. Hopefully at this point, you guys have all gotten my feedback. And what I'll do now is just kind of walk through the problems I saw and give you some hints on how to resolve them. So as always, please make sure you document your code thoroughly. Please make sure that you address my comments from the earlier assignments, especially assignment 1B. We'll spend a little time on that because there were some tricky issues that plague people a bit. And then also make sure you always run the unit tests and the integration tests and make sure that they pass. And if they're not passing for some reason, please make sure you come to office hours or ask on Piazza to get help. So here's just a real simple issue. You should get in the habit of initializing things like the future list in the place where you actually need it, which is down further in the begin being threads method. And there's a couple of different ways to do it. You can either allocate it like we see here with a new array list, if you're doing kind of the classic Java for each loop or for each method style of programming, or more ideally, if you feel comfortable, using Java streams and initializing it with the collect method and a collector. That's really a better way to do it. And we'll talk about that more when we get a little further down in the review here. Let's move on to some other issues. Make sure that you're passing in the right method call to create executor service. If you read the comments, it says you should be using the get thread count method to return the number of threads. So please make sure you do that. And then down here, if you're going to do the grad student version of this with a stream, make sure that you assign the result that comes back from the stream to the M future list field. And if you don't do that, then it won't be initialized properly. If you're going to use the stream model, which is what this example is doing, then make sure that you use method references, not Lambda expressions. As always, your IDE should prompt you to make that conversion whenever you can. And also make sure that you use the right collector here. This version doesn't make any sense, and so it doesn't work. You should be using the toList collector, which collects the stream up into a list, which you then, of course, should assign to the M future list field. Continuing down with our analysis, we're now in the await completion of futures method. And there's a bunch of issues here. First of all, make sure that you don't call the call method on the result that you get back from the future. The future should basically return the result of having a thread in the background call the call method on the being callable that's passed in. You do not want to be calling that method yourself. That doesn't make any sense. That should have been called by the thread in the thread pool way before you get the result back from the future. And another thing to note, you don't need to be calling shutdown now. And there's no benefit in doing that. That's actually called later in the driver program when you actually run the program or run the simulation. Here's another thing to keep in mind. The grad student version needs to do something appropriate here. And what you want to make sure is you're passing in the method reference again, as opposed to a Lambda expression. And then you also have to make sure you call the get method on that in order to be able to get the results. So take a close look at the specification, and this code isn't quite right. Likewise, this code is also not quite right. It's close, but you have to make sure that the supplier that you get back from the rethrow supplier adapter method has its get method called on it. Now let's move into the shutdown now method issues. A lot of people had problems with this. We're going to hopefully get this improved with our unit tests so that these problems are caught automatically henceforth, so I don't have to try to remember all the different variants that are incorrect. But first and foremost, make sure that you check to see whether the future is already canceled. Make sure you check to see if the future is already done. And only if it's not already been canceled and not done should you call the cancel method. Otherwise, don't call it. If it's been canceled already or if it's done, no need to cancel it again. And there's a bunch of problems people had. So the most obvious one is not to do either of those checks. There's some other less obvious ones that people had problems with. This particular code, I guess people got confused because the parameter that's passed to cancel is a Boolean that says true or false. And what that means is, should the cancellation take place immediately or should it be deferred? It doesn't mean should cancel be called at all? So this code here is incorrect because it's making the Boolean parameter passed to cancel be true or false if the future's already been canceled or if it's done, which isn't at all what you want to do. That doesn't have the desired effect. You want to only call cancel with a true parameter if the future has not been canceled and the future is not done. So this code is not quite right. There's many variants on these problems. Some people would only check to see whether the future was canceled. They wouldn't check to see if it was already done. So make sure you check for both conditions. And down here, people also got things wrong in terms of how the expression should be done. So for example, this code will call cancel if is canceled returns true, which of course is not what you want to do. You don't want to be canceling something if it's already been canceled. And also make sure you pass true to cancel, not false to cancel when you do call cancel. And that basically, if you read the documentation, you'll see why you want to do that. That says cancel it right away, interrupting it if necessary. And then yet another problem here, this condition expression is simply incorrect. So make sure you think carefully about the Boolean conditions. And they can be a little bit tricky when you've got negations and ands and ors. So think about that carefully. There's a bunch of ways to do it right, but there's also, as it turns out, a bunch of ways to do it wrong. So make sure you do it right. And this is also something to be familiar with because undoubtedly when we have our next quiz, which will occur a week from today, you want to know how these frequently made mistakes should actually occur to be fixed. You want to know how to fix them. Here's yet one more example of an incorrect shutdown now method. In this case, you want to make sure that if you use the streams approach, which is perfectly fine to do, you want to make sure that you put the right filter condition in to only let things through the filter that have not been canceled and are not done. And then another subtle issue, but pretty obvious if you read the comments and you watch the video, this is the wrong shutdown method. So there's two different shutdown methods, and you want the one that shuts down now, not the one that says, shut down whenever you feel like it. So you want the one that does it immediately. Now let's turn our attention into the being callable issues. And these were things that really were left over from assignment 1A. People still hadn't fixed them properly. So make sure that you move the call to acquire Palantir and the check to see if the Palantir is null outside of the try finally block. You want that to go first. So you don't even go in the try finally block unless you've got a valid Palantir. You also don't need to catch an exception here at all. There's no purpose for doing that. It doesn't get you anything. And also make sure that you refactor your code so that you don't have to check if Palantir is null when you call release. If you set things up correctly and move the acquire Palantir call outside of the try, then you never have to worry about checking to see if the Palantir is null before you release it. This is another variation on the theme. This is even more problematic. It doesn't actually have a try finally block at all. So if gaze happens to throw an exception, then the Palantir will not be released properly. And make sure that you release the Palantir appropriately. Don't reach down and use implementation artifacts like M manager and so on. Just call the release Palantir method to do the work for you. All right, then something else that was left over from assignment 1B were some problems people had with the spinlock hash map manager and the various spinlock implementations. So one of the things we're always doing in our assignments is we're always trying to improve the unit tests. And so we came up with a better way of testing for some erroneous conditions in the assignment 2A tests that we didn't have in assignment 1B. So some of the code that you wrote in assignment 1B will magically stop working or be flagged as incorrect because it was never correct. It's just that our tests weren't thorough enough to catch that problem. And that's a perfectly good experience point for the real world of software development. People are always taking time to improve their unit tests and integration tests. And so there's never anything to be ashamed of having to fix code you thought was working that in fact was never working, but the tests weren't thorough enough to catch the problem. So here's the problem. The problem is that the replace method or put method, if you use put, actually can return 3 different values. And the reason why I can return 3 different values is because it's using reference types as you must for the parameterization of the Palantiri map, of that hash map. So the second parameter for that is a Boolean with a capital B. And when you have a Boolean with a capital B, it's a reference type, not a built-in type or a native type. And as a consequence, there can be 3 different values that you get back that are Boolean with a capital B types values. One is null, and null will come back if the Palantir parameter is actually not in the map at all, which could happen if somebody just passed in some random piece of gobbledygook as the Palantir parameter. So in that case, you get back a null. The other value you can get back is if you pass in true, and for some reason you have a bug in your acquire code, and you get back a true. So if you get back a true when you pass in true, that meant it didn't actually change the value. It was already basically a value that was in use. And so what you want to do here is you want to differentiate from a value that's true versus a value that's false. What you want to do when you call this is you want to get back a false value. And if you get back the false value, that's a good sign, because that means that that's what the current value was, and now you're setting it to true, which means that it's now available for use. If you get back a true, however, that means that you have another bug in your code somewhere else. So there's 3 values, and checking to see if replace returns true won't catch the case where it returns null. It'll give you the wrong result. So you'll have to think about how to do this. And there's various ways to do it. You're welcome to choose the one that you feel most comfortable with. But until you get it right, the test will fail, and you'll be somewhat perplexed if you don't understand the semantics of replace. More broadly, this is a great example of why unit tests are so helpful, because they make it possible to catch these kinds of bugs that are otherwise very subtle and hard to reason about if you just look at the code. Let's take a look. A final problem that I saw still lurking in some people's code was the lock implementation in the reentrant spin lock or the spin lock, either one. That's basically the same thing, just slight variant in the semantics, because reentrant spin lock uses an atomic reference, whereas the spin lock uses an atomic Boolean, but the same basic idea applies. So make sure that you're very careful in how you do your condition check. And if you'll find this most likely when you run the stress test or the integration stress test, and you'll get some failure even though your unit test passes. And the reason for that, of course, is that many synchronization problems and race conditions don't show up until you run the code, as opposed to try to do some static analysis of the code. So if you get that problem and your tests are failing, it's most likely because you haven't got your condition correct here. And this is indeed a good example of something that's not correct. So this will actually exit prematurely if another thread owns the lock, which is not at all what you want to have happen. If another thread owns the lock, you just want to keep spinning until it releases the lock, the other thread releases the lock, and you get a chance to atomically acquire it. So those were the key official mistakes that I saw when I reviewed all the code for assignment 2A. If you have any questions, of course, please don't hesitate to come and ask, and we'll make sure that you get the help that you need in order to get a perfect solution.